Welcome back to Home Comfort Advisor. In this chapter, we're talking all about air sealing and debunking some common myths you've probably heard about it. If you've ever been told that tight houses cause mold or that houses need to breathe, those are some very common misconceptions out there, and I'm going to clear them up for you right now. Houses don't need to breathe, but people do. When people talk about houses needing to breathe, they're actually talking about controlling moisture, not allowing random air leaks to occur in the house. So why do people believe that houses need to breathe? To answer this question, I need to give you a quick history lesson on home construction. This myth comes from an old school mentality within the construction industry dating back to the 1800s and early 1900s. Back in that day, when homes were built, they were very leaky because of the way they were constructed. There were no top or bottom plates to walls, which created big air leakage paths from cellars and crawl spaces all the way up through walls and into attics. This early type of framing is called balloon framing because it was lighter than post and beam style construction that was used before, and it was held together with nails instead of mortised beams and joints. Builders also didn't have exterior wall sheathing like OSB, plywood, or foam board materials that we have today, and instead the wood siding acted as the sheathing, except it wasn't really an air barrier like real sheathing is today. Those leaky homes brought in plenty of air from the outside and kept them dry year-round, but as you learned earlier in this course, that uncontrolled airflow also comes through holes in walls, foundations, and around windows and doors, and through ceilings from attic spaces. That uncontrolled airflow also brought with it dust, pollen, moisture, and other things that you don't want coming inside your home, and that still happens today in leaky houses. As time went on and building techniques advanced, homes were built with top and bottom plates and wall sheathing, not only for structural support, but also for fire safety. When an old leaky house catches fire, that dry wood and airflow really accelerates how quickly a fire can spread throughout the house. So building codes also started requiring draft stopping, which included better framing techniques, adding fire-resistant insulation in some places, and fire-resistant sealant to places where air leaks in and out. As home building techniques advanced, a side benefit was they got less and less leaky. The problem was that before this time, nobody really had to worry about removing moisture created inside homes since they were so leaky. And now that houses were being built tighter, any moisture found indoors wasn't naturally leaving by air leakage, and issues with moisture damage started becoming a thing. Remember in previous chapters when we talked about fixing moisture issues before air sealing? Well, this is the original example of why. So to combat these new issues builders are finding, they started installing exhaust fans in bathrooms with showers and tubs and in kitchens to move the steam from cooking food outside. Sometimes that was done right, but often it was not, and instead the vents just dumped the moisture into attic spaces and made problems worse. As more and more homes fell victim to issues with moisture damage, eventually builders realized they had to start paying attention to how water drained from roofs onto walls and around windows and doors. And so flashing these intersections were eventually required by code to prevent water damage in those areas. Many builders didn't understand the reasons behind all these new requirements, and frankly a lot still don't today. And so they blame the cause of these new moisture issues on tighter houses, and that same basic misunderstanding is still prevalent in the construction industry today, unfortunately. How can we tell how leaky houses are? Professional home energy auditors can determine how leaky houses are by using a diagnostic tool called a blower door system to simulate air leakage on houses. A blower door system has a powerful fan secured in a metal frame that's covered by a big vinyl cloth, which is mounted in an exterior doorway. A pressure gauge controls the fan speed and measures the airflow through it, along with the pressure difference between indoors and outdoors. When the fan's turned on, it sucks air out of the house, which lowers the indoor pressure relative to the outside. This is called depressurization. This causes air from the outside to be pulled into the house through any cracks, gaps, or other holes in the home's pressure boundary. As the blower door fan runs, the system measures the rate at which air flows through the fan to maintain a specific pressure difference. We use cubic feet per minute, or CFMs, at a pressure difference of 50 pascals as a standard to measure air leakage in homes, and this is referred to as CFM 50. I like to compare a house's CFM 50 to its total square footage, including any unfinished basement area. Doing it this way, you can estimate air leakage rates for houses based on their total square footage and when they were built. In general, the older the house is, the more air leakage it's going to have, and the ones built in the 1800s and early 1900s are the leakiest. For example, if an average quality two-story house on a basement built in 1990 is 3,000 square feet, which is basically 1,000 square feet per floor, it should have an air leakage rate of about 3,000 CFM50, 1 CFM per square foot of house. If that same house were built today under current building codes, it would be much tighter, and the CFM50 number would be more like 1,500 CFM or less, a half CFM per square foot or less. Technicians can use this CFM50 number to calculate the building's air changes per hour at 50 pascals of pressure, which is called ACH50. It's just another standard measurement of assessing air tightness in buildings that also accounts for the volume of air that's inside them. Think of ACH like this. It's the number of times that 100% of the air inside a house can leak out every hour. To me, using ACH50 is less useful and intuitive than using CFM50, so for the purposes of this course, if I'm referring to an air leakage rate, I'm referring to a CFM50 number. So how do we find air leaks? So you might be thinking, that's all great to know, but how do I find out where the air is actually leaking out of my house? The blower door test can also help pinpoint where specific leaks are coming from when it's used in combination with an infrared camera or a smoke pencil, which can visually show that air movement happening. When using an infrared camera, you can locate points of air leakage by finding hot or cold spots in the thermal images like you see in these examples. Bright colors are warmer surfaces and darker colors are colder surfaces. So if you're using an infrared camera in the summertime when the air is hot outside, you'll be looking for bright colors that appear to fade away as the origination points for air leakage. In the wintertime, the opposite is true. Since colder air is outside, you'll be looking for darker colors that fade away as the sources of air leakage. The best time to get a blower door test done is before you even start planning for any improvements on your house. By getting an air leakage rate on your house beforehand, you'll know how bad your situation is and how much it could potentially be improved. The blower door will give you a baseline number to start from, and after you've identified where the leaks are coming from, you can estimate how much tighter you can make your house. So how do we air seal houses? Air sealing is all about blocking uncontrolled airflow through holes, gaps, and cracks between building materials. And different sealing materials are needed for different applications. Let's go over a quick list of the most common air sealing materials and when you might use each one. The most common air sealing materials are caulking materials, expandable foam, spray foam insulation, liquid sealants, specialty tape, and blocking materials. Let's talk about silicone caulk. Silicone caulk versus siliconized latex caulk, specifically. So 100% silicone caulk is durable and flexible, and it's ideal for using outdoors or places where you want a long-lasting waterproof seal. It's generally much more flexible than siliconized latex caulk, and it won't crack nearly as easily with changes in the weather. One drawback is that it's not usually paintable, so keep this in mind depending on your project. Places to use 100% silicone are around windows and doors where the window needs siding, brick, or trim, and anywhere you see an electrical, plumbing, HVAC, or a low voltage line penetrating through an outside wall. That includes above ground walls and foundation walls. Siliconized latex caulk, on the other hand, is easier to work with indoors and it can be cleaned up with a wet rag or a paper towel. This is what you should be using to seal window and door trim to walls. This kind of caulk is paintable as well. There's also something called fire caulk, which is a special kind of caulk with fire retardant properties that are sometimes required to be used around metal flue pipes, chimneys, and other high heat sources. You can also use this to seal any penetrations through top plates of walls, but you wouldn't want to use it around windows and doors, sealing those to the walls. The second one is expandable foam. There are two basic types of expandable foam that come in cans: low expansion foam and fire retardant foam. Low expansion foam is also called window and door foam. This stuff is great for filling gaps around windows and doors between the surrounding wall framing, as it only expands a little bit to fill those gaps, so it doesn't bow the windows or doors. In fact, if you have a modern house with vinyl windows that are hard to open, there's a good chance that the windows either weren't installed correctly or regular expandable foam was used to fill the gap around them, and your windows may actually be bowed out from that. You can use this same foam for sealing holes like you would with fire retardant foam, but it doesn't cure as hard or have the fire retardant benefits. If you're air sealing around fireplace chimneys, flue pipes, or other heat-producing items that penetrate the exterior of your house, this is the foam that you should use. It creates a seal between these building materials while reducing the risk of fire spreading, should one occur. If you're air sealing electric, plumbing, and gas lines going through the top or bottom plates of walls, or those running through exterior walls or foundation walls, you can also use this type of foam there. There's also non-fire retardant versions of expandable foam too, but a lot of the canned foams now include fire protection, and I just recommend getting those instead, as there's not a big difference in the price between the foams. The third thing we're going to talk about is spray foam insulation, specifically closed cell and open cell spray foam. Spray foam insulation is a great material for filling and air sealing larger holes and gaps in your home and providing insulation in one application. There are two types of spray foam most commonly used, and they are open cell and closed cell spray foam. I'll cover spray foam insulation in more detail in the next chapter on insulation types, but the three basic things that you should know here are: spray foam is best used to air seal and insulate building materials that are hard to reach. The thicker it is installed, the more R value it provides. There are DIY kits that you can use on your own and professionals that you can hire to install this product. However, in my experience, for the vast majority of situations, I would highly recommend that you hire a professional company rather than try to do it yourself. There's a lot of things that can go wrong, and you won't be able to do a comparable job any cheaper than a pro. I'll explain more about this in the next chapter on insulation. The fourth air sealing item is specialty tapes. Tapes like Zip System or other construction grade options are ideal for air sealing around gaps between framing and sheathing materials. These tapes have strong yet very flexible adhesive and are designed to be stretchy and durable, and are mainly used as part of properly flashing windows and doors before any new siding is installed. Vapor barrier tape is another product used for sealing plastic vapor barriers together, as well as air sealing air barrier materials and house wrap products. These two types are the main ones I personally use and recommend. Stay away from traditional duct tapes. Most of them are not made to hold their adhesive long term, especially when they're exposed to outdoor elements or used in attic spaces or crawl spaces. And they'll eventually lose their grip and their ability to air seal over time. Don't believe the marketing hype and just don't use duct tape. Number 5 is liquid sealants. These are more recently invented specialty products and are not commonly used in the construction industry yet. They're basically like a liquid version of latex caulk that can be applied with a pressure sprayer to seal gaps in framing or between two different building materials like drywall and wood or wood and metal. The Zip System brand has a liquid flashing product that can be used instead of their flexible tapes, and other companies like Owens Corning has a product called Energy Complete Sealant that is more of a professional use product, but it can be used to seal all kind of cracks and gaps in homes under construction or when they're being renovated before drywall is installed. Number 6 is blocking materials. To seal large gaps and holes in your house, you'll need to use something bigger than what caulk or expandable foam can fill. So choosing an air barrier material like foam board, wood, drywall, or Reflectix bubble wrap are good options. Some common areas that use these materials are where cantilevered floors cross over foundation and exterior walls, where room additions or exterior porches with roofs are connected to houses, openings from attics leading between floors in 1.5 and 2.5 story houses, and covering the tops of mechanical chases and fireplaces. Let's go over a few of these now. Number 1, foam board. It's great for covering larger holes like those that you'll find in attics or basements, and it's easy to cut and install by yourself. Stick with 1/2 inch thick foam board or thicker for extra strength, durability, and better R value. Wood and drywall. These are good choices for bigger gaps or structural areas where foam board isn't suitable, but you don't want to use drywall in areas with high humidity like attics or crawl spaces. Wood should be used wherever blocking is needed to keep rodents and pests out, and stay away from OSB or particle board in those situations, as they are weaker than plywood or dimensional lumber. Reflectix and Thermoply. Reflectix is a brand name for bubble wrap insulation that you've probably seen before in hardware stores or online. It usually has a shiny silver face to it, but sometimes it's white. It can be used as a flexible air barrier to cover large openings when air sealing, and it can be stapled or nailed in place before applying a sealant to it. Thermoply is a thin and sturdy air barrier material often used in new construction behind fireplace inserts, bathtubs, showers on exterior walls, and many other locations. It's easy to cut and can be installed very quickly. Any seams and adjacent pieces of thermoply should be sealed with special vapor barrier tape or metal tapes, unless a silicone caulk or spray foam sealant is used. Now let's talk about cardboard. Okay, this one is the least recommended because it's not a very durable material, but if you're in a pinch and you just need a quick fix, cardboard can work to block large openings between floors or chases and attics. It's one of the most common materials used by high-volume home builders since it's the cheapest option. Just remember, it's not a good long-term solution, as moisture in the air can degrade the cardboard over time, and rodents can easily chew through it. You also can't use it near heat sources like fireplaces or flue pipes. All right, now let's talk about where do we actually air seal houses. This is going to be a pressure boundary review from earlier in the course. So in Chapter 4, we talked a lot about pressure boundaries, and now it's time to put that knowledge to work. Remember, the pressure boundary is the part of the house shell that keeps conditioned air inside and unconditioned air outside of your house. You want to air seal any holes located in the pressure boundary, starting at the top and the bottom first, then addressing any leaks around windows and doors. The pressure boundary usually consists of the drywall or plaster on walls and ceilings, windows and doors, rim joists, and foundation walls on houses with basements. Anything that creates a hole or a gap through these parts of your house causes air leakage and needs to be air sealed. If you have a crawl space, the pressure boundary can be the wood subfloor if it's airtight, but most likely it's not. So the foundation walls end up being the pressure boundary due to the air leakage that typically occurs between the house interior and the crawl space below. 9 times out of 10, if you have a crawl space, most of your ductwork will be located inside of it. So it's best to have the thermal and pressure boundaries surrounding that space, which would be the foundation walls. Whether you have a sealed crawl space or one with vents in the sidewalls, if there is HVAC ductwork located in your crawl space, then your goal should be to completely air seal and insulate the interior side of the foundation walls and rim joists to create a properly sealed and conditioned crawl space. Again, this assumes you don't have any moisture issues present near the foundation and the ground around it slopes away from it. Sealing the crawl space is done most often with expandable foam applied with foam guns to any big holes found in the rim joists and foundation walls, then by spray foam contractors applying 2 inches or more of closed cell spray foam to those same areas. If your home is built on a concrete slab, then the slab is part of your pressure boundary, and the only place that you can really air seal the slab is where the bottom plates of the exterior walls sit on top of it. This is usually only possible to do with flooring and base trim removed, so unless you're building a new home, addition, or doing a big renovation, air sealing this gap probably won't be possible. If your home has a basement or a cellar, then the pressure boundary is your basement or cellar walls and the ground or concrete slab floor below. Anything penetrating those areas to outside should be air sealed. Prioritizing where to air seal. Now let's discuss the places to air seal where you'll get the biggest payoff for your time and money. Number 1 is seal up the top first. Start with your attic and look for anything going up into it from inside your house. Since hot air rises, you want to air seal any attic hatches, recessed lights, bulkheads, interior soffits, and duct chases going up through the ceilings with attic space located above. Those are going to be the big leakers. Another place to check in your attic is anywhere the ceiling height changes from one room to another. The difference between those ceilings creates small knee walls in the framing that are often directly open to the attic spaces above. Many times this will be present on interior walls, which will cause a lot of heat loss and air leakage through those walls into the attic spaces above. If you find any wall cavities that are open to the attic, this is where you'd want to install blocking materials at the top of each wall cavity right at the ceiling level, then air seal that material to the surrounding framing and drywall. The smaller stuff that really adds up are the electric plumbing, cables, and HVAC lines that need air sealed where they go through the top plates of your walls. And speaking of those top plates, those also need to be air sealed to the drywall on both sides anywhere that you can reach them. In fact, sealing top plates can make a big difference in the overall air leakage of your house, and it's something that most people have never thought of as a place that actually leaks air. Now, before we move on here, it's important to take a step back and consider your options for sealing up the top of your home. While you can certainly air seal all the places that I've already mentioned one by one, another option to consider is sealing off your attic entirely and installing spray foam insulation to the underside of your roof decking to condition the attic space. When I inspect houses, the way I determine whether or not it makes sense to spray foam the attic really kind of comes down to a few considerations. Is there going to be ductwork located in the attic? And if so, is the heating and cooling system located in the attic as well? If the answer to either question is yes, then it's a good candidate for conditioning the attic space. The next question is, how big is the attic inside? Some houses have very tall roofs that can extend 20 feet or more above the ceiling level inside the attic, and often this equates to a lot of extra roof area that would need to be reached and spray foamed, which can make the cost even more expensive. Conversely, if the attic is pretty small with a lower pitch roof, it may be easier to condition that attic instead of trying to reach up and air seal every little penetration going through the ceiling. For these smaller attics, it really just depends on how much room there is for someone to work inside that attic and effectively reach the entire attic space. Another question I always ask is, are there parts of the attic that are not accessible at all? For example, if you have any cathedral ceilings in your house where the roof deck is directly above and there's no way to access it, then you'd really need to remove the drywall ceiling and the existing insulation in those areas to spray foam the entire roof deck properly. Depending on how much square footage you have of cathedral ceilings, this could get pretty expensive and intrusive to accomplish. This is especially true in 1.5 and 2.5 story houses, so you'll have to weigh the cost benefit and decide whether it's worth it to you to do something like that. Another example is with small inaccessible attic spaces, like the ceilings above dormers and the areas behind knee walls in 1.5 and 2.5 story homes. Again, to do it right, you'll need to remove some of the drywall to be able to reach the entire roof deck behind those areas. Another question I ask is, how long do you plan to live in the house? As with any home improvement, there's a return on investment factor, and generally speaking, conditioning your attic space can be fairly expensive to do correctly, and it usually doesn't have a great ROI in terms of dollar savings on utility bills. There's a lot of factors that go into that ROI, but you get the idea. Just something to consider if you're only planning to stay for a few years or so. Step number 2 is seal the bottom of the house up really well. After you've tackled the attic, go to the basement, cellar, or crawl space if you have one, and this is where cold air sneaks in during the wintertime. Seal all the holes in the rim joists and foundation, especially where utility lines enter the house. Use expandable foam or 100% silicone caulk here. Usually the AC line set runs through a big hole that is often left unsealed. If you can see daylight shining in from outdoors, that's a hole that you need to seal. If you notice cobwebs in certain areas of your home, there's also a good indication there that a hole is nearby that needs to be air sealed. Cantilevers are another big point of air leakage generally found towards the bottom of houses. A cantilever is any floor that extends out from the house and is exposed to the outdoors or even a garage area that isn't heated and cooled. These are commonly found underneath fireplaces that extend out from the house, under garden tubs and bathrooms, and where the second story of houses is larger than the first story or the basement below, and it will cantilever out. To fix cantilevers, you may need to remove the wood or vinyl siding underneath them first in order to fill them with insulation and seal the perimeter, especially where they go into the house. It's also possible to fix them from the interior space if the inside isn't finished yet, like in basements where the cantilever is between the basement and the first floor. If your home is finished outside, you need to cut out the drywall at the edge of the ceiling right in front of the cantilever in order to insulate and seal it properly. 3. Finally, check your windows and doors. Believe it or not, windows and doors are usually not the main source of air leakage in homes. As we've discussed, usually the trim is where air leaks most around windows, and the trim can be easily sealed to the surrounding walls and window frame with siliconized latex caulk. If the trim has been sealed up and you're still feeling air leakage near your windows, you can do a couple more things. One option would be to use rope caulk or cord weather stripping to fill small gaps where window components don't meet tightly together. Rope caulk is like a flexible putty that can be easily installed and removed later without leaving a big mess. Another option is to install a self-adhesive plastic over the entire window, which seals to the surrounding trim. This isn't the most attractive option, but if you've tried the other techniques we've already mentioned and they don't help, and you're not willing to replace your windows yet, this is another cheap alternative that can act as a band-aid for now. Make sure all your windows shut and lock completely too. This sounds really basic, but during inspections over the years, I've found windows that are cracked open or otherwise weren't shut, and the homeowners didn't know it, and it didn't lock completely, and that made the rooms they're in less comfortable year-round. To sum up this chapter, air sealing is one of the most effective ways to improve comfort and energy efficiency. When you stop air from leaking in and out of your house, your heating and cooling system doesn't have to work as long to keep you feeling comfortable year-round. Air sealing should always be done before adding insulation. In the next chapter, we'll discuss the different types of insulation and the best bang for your buck options for different applications. I'll see you in the next chapter soon.